So, good afternoon, everyone. We will start our session. So, I am Riddhi Gohel, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Intelligent System. The 7th edition of the conference is being organized in a hybrid mode, digital and physical mode. So, physical event was held in Ahmedabad, 27th April yesterday, and the virtual event is being held through Zoom today. So I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 8 presentation, and each presenter will be given 8 minutes for the presentation and 2 minutes for the question answer. So on 7 minutes, I will raise gentle reminder to conclude our presentation. So kindly follow the time limit for the presentation. There is another request to all the participants. Please stay connected with us until the closing remarks. If you have any query and update, then you can write it to me chat box. So just before we get started, I would like to introduce to all our chair of the session, Professor Nilesh Popat Samble. So Professor Nilesh Popat Samble is Associate Professor in Vishwakarma Institute of Information Technology in Savitribai Phule University, Pune, India. So also he has 15 years of academic experience and presently working as a SPPP approved associate professor in the Department of Information Technology. He has done a PhD in the computer science and engineering from Kalinga University, Raipur, on research problem statement study on relationship standard mining calculation in data mining. He is a SPPPU approved PhD research guide. He has also published 50 plus papers in national, international conference and journals. He had filed the published 14 patents and the 3 copyrights. He is the author of couple of books with the international publisher like Lambert. So we welcome you, sir, in this session.
Thank you, ma'am.
Yeah. So I would like to invite our first presenter.
Harshit.
Yeah, Harshit.
Good afternoon, everybody. I'll quickly share my screen.
Just a second, sir. I will announce your name, Harshit Jha. And the paper title is Analysis of Deep Learning, Deep Neural Network for Intrusion Detection System.
Thank you so much. Let me know if you guys can see my screen. Give me a second. Yeah, is my screen visible?
Yes, sir, it is visible.
So good afternoon, everybody. Good afternoon, sir. Good afternoon, ma'am. The topic of our project is performance analysis of deep neural networks for intrusion detection system. And I am the author, Harshit Jha, and Maulik Khanna also has joined me as my co-author to present a report. So the agenda would be introduction, aim, then we'll talk about the system, the methodology, and the conclusion and future work. Starting with introduction. So as of 2022's January report, there were around 5 billion active users, and that amounts to 60% of the world population. So another report suggests that there would be around 30 billion devices by 2025. And modern intruders are evolving and are breaking these existing firewalls. So one of the ways to deal with such attacks is to develop intrusion detection system, which can actually identify such malicious behavior and can actually initiate some certain activities to secure a computer from these kind of intruders. The aim of our project was to compare the deep learning model with various ML classifiers on various assessment metrics, the previous work of intrusion detection system, and all the approaches that have been used till now to explore this category. In comparison of previous works, we have showed that how our work works better at an average to give better accuracy, and show that there is a requirement for better and improved data sets. So what exactly is an intrusion detection system? So an intrusion detection system is a security technology that monitors a computer network or system for signs of malicious activity, policy violations, or unauthorized access attempts. So IDS works by analyzing network traffic, system logs, and other data to basically identify suspicious or abnormal behavior that may indicate a security breach. So the types of IDS you can see here are firstly based on monitored platform, are network-based, host-based, and hybrid IDS. And based on detection technique, it is signature-based and anomaly-based. So firstly, talking about what kind of IDS we are looking for. So based on the detection technique, we are looking for anomaly-based IDS, because mostly signature-based IDS is not technically used that much, as what it does is it identifies the different or outliers from the data that is present to us. And then the reason people don't use signature-based IDS is that it sometimes detects a lot of normal activities as intrusion. So anomaly-based IDS, which basically learns from the previous anomalies, such as previous DOS attacks, to identify further DOS attacks. That is on the principle on which most of the IDS systems are based. This is a kind of a hybrid IDS that is used, and most of the IDS that is present in the industry today is kind of a hybrid IDS. Talking about the related work that has been done on IDS, so most of the related work is done on data sets such as NSL KDD or UNSW. So one of it shows that it was able to achieve an accuracy of 0.75 on UNSW. And like you can see that using anomaly detection using LSTM and attention mechanism to improve performance, Lin was able to get an accuracy of 0.96 on CIC IDS 2018. Further, I will not go in detail about all the other related work, but then we can clearly see that most of the related work is on NSL KDD and is able to achieve a good amount of accuracy, that is towards 99%. So coming to the viewpoint as to what we saw from what we inferred from this previous work, that mostly currently available datasets lack the features of real-time network, due to which most of the present anomaly detection IDS are not suitable for the product environment. In this paper, we have discussed that there is a need for newer datasets which are adaptive to dynamic nature of world of cybersecurity, are balanced, and are inclusive of different widely encountered cyber attacks. These are the few datasets that we have used, and and obviously these datasets are the mostly used datasets. KDD 99 and NSL KDD are the datasets on which 90% of the research are based. CIC IDS is relatively a newer dataset and is being used in some new research work, but still is not used in that big capacity. Maulik will continue with the methodology.
Yeah, thanks, Harshit. So before moving to the methodology, I would also like to add one point that since we are dealing with cyber attacks, so even an accuracy of 98% turns out to be not so good, because that would mean that we would be missing detection of 2 attacks out of every 100 attacks. So continuing with the methodology, we have used a DNN model, which is a deep neural network, and basically we have applied nonlinear transformations. That is how the DNN works. We stack hidden layers over each other, and every output from every hidden layer is feeded into the next subsequent hidden layer. So moving to the next slide. Harshit, can you please help me out? Yeah, thanks. So what we have proposed is that since we are using multiple data sets in this research that we have done, we'll be considering the input layer as the number of neurons equal to the number of features in the data set on which we are training the model. Also, our model has a completely connected architecture where every neuron in the current layer is connected to all the other neurons in the next layer. And via back propagation, we are using it as a learning mechanism for the model. Also, we have added certain dropout layers in order to prevent the overfitting of the model. Next set. So the model consists broadly of 4 dense hidden layers, and we are reducing the number of neurons in each layer subsequently from 1024 in the first hidden layer, next one with 768 neurons, third one with 512 neurons, and the fourth layer containing 128 neurons. Now, the output from the fourth hidden layer will serve as an input to the output layer neurons for a multi-class classification of the type of attack based on the data set that is being used to train the model. Now, we have used ReLU as our activation function instead of the sigmoid or the tanh functions. One reason being that the sigmoidal functions and tanh functions are actually, they face the problem of vanishing gradient, and ReLU is immune to it. Also, later we have used softmax activation between the final hidden layer and the output layer for multi-class classification. And as I've mentioned before as well, we have added dropout by 1% each to make the model more robust, so that we could prevent the model from overfitting. And next we have cross entropy as our loss function and Adam as the optimizer. Moving to the next slide. Okay, so the findings that we have come up with is that our proposed simple DNN model is working with an accuracy of 98.74 on an average over all the data sets that we have included in our research. And it is the best performing algorithm, with second one being the random forest with an average of 97.7. Now, the difference can be seen, especially when we compare performances over the newer CICIDS datasets. And this relatively easier approach gives great outcomes, and developing more complicated neural networks at this stage seems like an overkill. Continue to the next slide, Arshit. Would you like to take over? Yes, Arshit, would you like to take over from here?
Yeah, sorry, I was not able to open my mic. Yeah. So one thing that we have actually inferred from the findings is that even though our relatively simple, our algorithm that we're using is relatively simple, it is able to get very good results. And that is because most of the existing data sets that we have, they don't represent the current world scenario. And this actually shows that we need newer data sets, and we need to train models on those data sets to use these kind of algorithms in the real world scenario. So findings that we saw based on the datasets were that KD99, the best deep neural network gives about 99.03 accuracy on this. And it is a relatively simple database, as it has over 90% of the attacks that it covers is only DOS attacks. And it does not represent current traffic, and hence its model trained over KD99 are not up to industry standards. And as I told before, 90% of the research papers are based on KD99 or NSL-KDD, which is also a similar version of KD99 and is also outdated. Coming to UNSW, all algorithms except naive Bayes performs really well on it. And even though it is a relatively newer database, it consists very limited dimensions and covers lesser number of attacks.
Yeah, sorry for the interruption, sir. Hello.
Yeah.
Sir, you have only 1 minute left for the presentation.
Right. So as I told, that CICDS is a relatively newer database, and hence we can see there is a considerable drop in performance, and still our own algorithm performs really well. Now, just talking about the conclusion in the future work, we can see that the proposed solution gives very good accuracy on CICD, that is 97.53. And right now, this algorithm can be used if we are using CICDS as the base of all the network intrusion systems. But further, if we want to talk about the future work, we need better data sets, more complex data sets, and then make model according to that, so that we can use these kind of systems in real world scenario. Thank you so much. Any question?
Yes. Basically, what exactly your findings are from this research? Because in spite of only using the another database, what exactly the difference between previously used data sets are and the current data sets are? Which parameters, new parameters you have considered in this?
So basically, sir, we have honestly the parameters that we are using is currently just the accuracy. Even though we have used recall and precision, but accuracy was able to give us a good comparison. And what new thing we have done is that no research papers actually compare so many databases and algorithms. And what people generally do is they pick up a single database and then they try to increase the accuracy on it as much as possible. But what we have,
but if the data set if the data set is having the same attributes, then considering one data set or three data set, what it will temper?
Right. So generally the attributes are the same. That is what we are trying to explain. That even though we have went through data sets that the first data set that we have used was developed in 1999, and the current data set that we're using is in 2018. The amount of difference in those data sets is not that much. And there is no point actually working that much on these current data sets, because no matter how well we are getting the accuracy on them, the real world scenario is different. So we need new data sets to actually mimic that real world scenario, which doesn't exist.
So that's what my question is. If you are considering a newer world scenario in this 2018 data set, so which new attributes you have found that you have what we can say analyzed in this data from this data set?
One of the new attributes that I think, not attributes exactly, but one thing that we have found is that the difference of attacks. So right now, most of these data sets have predominantly only DOS attacks. And DOS attacks, even though are common, they are not the only thing that exists right now. So there are many more attacks, right? So that there are R2.
0 day, what about 0 day?
Sorry, sir?
0 day attack is there, no? What about that?
Yeah, so that's what's so basically different attacks, more attacks should be included. And when coming to attributes, probably attributes, I would say that the attributes haven't changed that much. As you know, the main attributes are that duration time and from where, I mean, what a network is they're connected to, their IP addresses and all that. Attributes haven't changed that much, but the type of attacks have changed. Right. So the type of attacks have changed and the main commonly used attacks have changed. So that is what the new dataset should be looking at.
Okay. Okay, fine. No issue. Thank you.
Thank you so much.
Okay. Thank you, Arshit, for the presentation. So we are moving our next presenter, Nirav Mehta, and the paper title is Data Collection for Machine Learning Model to Suggest Gujarati Recipes to Cardiac Patient Using Gujarati Food and the Fruit with Nutritive Values.
Am I audible, ma'am?
Yes, sir, you are audible.
Okay. My screen is visible, sir?
Yes, sir, it is visible.
Okay. So, myself, Nirav Mehta. I am a research scholar from the Atmi University, Rajkot. And my topic is data collection for a machine learning model to suggest the Gujarati recipe to the cardiac patient using the Gujarati food and fruits with the nutritive values. Ultimately, the Gujaratis conduct one of the most highest ratio for the cardiac patient. So for that, I think that we have to find a such kind of nutrition-based food and give the recommendation to the cardiac patient for their good health, so that this model is very useful for the cardiac patient to get the proper nutritive value food in a recommendation. So for that, in this paper, researchers try to create a data set for that particular thing. So we move on to the next slide. My outline of the presentation is introduction, work on the data collection, and the work specification for the paper is divided into the two different categories: analyzing the structural features for the nutrition-based recipes, and the second one is design and develop a data set for the nutrition specification for suggesting the Gujarati recipe. And at the end, we look for the conclusion of the paper. So let me move on to the introduction. As per the introduction, researcher try to collecting the data for the nutrition value of the Gujarati food. So this model is only work for the Gujarati peoples and who are living into the Gujarat and who have a cardiac problem of health. This model will recommend the such kind of Gujarati food recipe to that particular patient as per their body requirement or nutrition requirement body. So in this paper, researcher tried to define the 15 different categories for the particular Gujarati food items for the cardiac patient. Next thing, in this paper, researcher briefly specified the nutritive values which has been conducted by the particular product. Also has been specified in this paper. Next thing, in these, there are basically two type of data collection which has been performed by the researcher. That is a primary data collection. In that, the researcher tried to collect the food and fruits specification with their nutritive values calculation, and around 90 plus product which has been collected by the researcher to suggest the cardiac patient that they have to eat for to reach the proper nutritive values. So 15 different tables and around 90 plus product which has been designed by the researcher for suggesting or recommending the proper nutritive values food for the cardiac patient. So, as per this paper, we consider the two different aspects or two different part of the paper. The first thing is analyzing the structural features. In this point, we covered the different categories of the food. That means we can say that if anyone take the lunch, then what they have to eat. If they want to eat the breakfast, then what they have to eat. If they want to take dinner, then what they have to eat. So as per the categories, there are the 15 different categories which has been analyzed by the researcher and divided into the 15 different categories to recommend the food. And into the second thing or second half of the paper, the researcher tried to design and develop the data set for the particular 90 plus product with the nutrition specification. So let's move on to the first aspect of the paper, analyzing the structural features of the recommendation system. So as per the research, we can say that any cardiac patient have to solve their problem, they must have to eat a proper nutritive based food. So as per the requirement of the research, the first of all we fix the structural feature of the food. That means what they have to eat and how they have to eat the particular items. So for that, first of all, researcher try to collecting the different kind of food, and on the base of dividing the food and fruits into the different categories, and at the end finally researcher divided those food and fruit into the 15 different categories which are listed in the following table. For example, if we want to set nutritive value, uh, everything is considered with the nutritive value, but here you can see that the researcher tried to specify the main meal. Now, main meal is a specification of the table. In main meal, there are some of the products which has been taken under the main meal or given to the cardiac patient, or we can able to recommend to the cardiac patient. Then after we can see that nutritive value for the snack. Then after main meal as a dal and sabzi. These all are items are considered as a Gujarati food, leafy vegetables, other vegetables, then after Sambara, then after milk products. So this data set is specially designed for the cardiac patient, which is not available into the uh, uh, anywhere. This data set is a primary data set which has been prepared by the researcher as per the requirement of the cardiac patient. So for that, get the survey from the particular cardiac hospital in Rajkot, and then get the suggestion from the particular doctor of the cardiac that what they have to eat and which kind of food the cardiac patient should have to eat. And on the basis of that, this specification of their products which has been designed by the researcher. So these are the 15 different categories which you can be able to see over here. The combination of the particular foods also is being available for here. So this is the first half of the paper that researcher designed the particular 15 different categories, and on the basis of that, each and every food and fruit item which has been bifurcated and put under the particular proper heading, and then find the nutritive value for them. So into the first para, we designed the 15 different categories. Now we are moving on to the second half, that design and develop the data set for the nutrition specification. Now, what the 15 category has been defined in that we put the different products or different items under the particular category. So let me see on the from the start. Okay. First of all, when we design and develop the particular data set, a researcher have to face such kind of problem to find the nutritive value for the particular food. So researcher perform the category or read the different kind of research paper. On the basis of that, we specified that we must have to specify the quantity of the food. That means if we are taking a roti, then we have to suggest them one medium size roti or one small size roti or one big size roti that contains a different kind of nutrition. So there is the problem which has been facing by the researcher. And after getting the solution of that particular thing, then researcher add the particular quantity of the particular food, and on the basis of that find the nutritive value from for that particular food, uh, which is basically required for the cardiac patient. So in the second half, 15 different tables and contain 90 plus products over there. So into the next slide, we are moving on to the main meal. So we can see that researcher design a table with a graph. Uh, as per the knowledge given by the cardiac hospital doctors, that any cardiac patient requires the four most important parameter which has been required as a nutrition in a cardiac patient body, which are protein, carbohydrate, fat, and the fiber. So protein is most important parameter. So on the basis of that, uh, they suggest the such kind of food which contain the more protein. So it will help to the cardiac patient body. So on the basis of that, the main meal contains a different kind of thing. Here we can see that into the x-axis, it will contains the name of the particular product, which is plain steam rice. Then after it also specify the amount, one small bowl. Then after roti, one medium size. Then after we can see that bakri, that is one medium size. In this way, we define the particular such kind of product, and into the y-axis we design the nutritive value for the particular product. So if we give the suggestion or recommendation to the particular cardiac patient of a steamed rice, then it contains the different kind of proteins, carbohydrate, fats, and fiber, which has been shown into the figure. So each and every product has been divided as per the specification of a nutritive value. So this is the table number 1. As per the table number 2,
Sorry for the interruption, sir. Hello.
yes,
Sir, you have only 1 minute left.
okay, no problem. So as per this way, we have table number 2, table number 3. It also categorized with the different products as per these values defined. The table number 4, table number 5. Here the table number 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. These all are the tables and with the product specification with a nutritive value. When we found these particular values of the nutrition, at the end we have to calculate the calorie on the basis of that. So if we have to recommend a such user to a such kind of food, we must have to based on the calorie, that how much calorie they have to consume. So these are the parts on which we can define the calorie, and on the basis of that, we can able
Yeah.
to give the recommendation to the cardiac patient for the good health. Thank you. This is from my side. Any questions?
Regarding fruits, it's fine, sir. We
Yes.
can predict the nutrition value,
Yeah.
all that thing. But for rest of the food, depending on the ingredients, which number of people can use, number of ingredients,
Yes.
how your system has calculated the value of this fats, fibers, and proteins from it?
Yeah, sir. What happened generally in a Gujarati family, it takes the such kind of taste of a particular food. So we cannot predict that particular taste, or we cannot get the particular ingredient from that. But we just have to define the quantity of that particular food, and on the basis of we can justify the particular nutritions of the particular value, sir.
No, but the from nutrition value, it is precisely on the basis of ingredients which are used. For
Yeah.
example, which vegetables are used, what quantity of what we can say species are used. In that, depending on that only the values are calculated, right?
Yeah, but I saw this such kind of research paper over there. In that, they calculate these kind of values on the basis of these, and there is
No, this is generic. This is means what we can say. These are the standard values which are being
yeah,
defined.
yeah, sure,
Depending on
sure.
the quantity, the values are being defined.
Yeah, sure,
But
sure.
if the making of particular food, it cannot be same, right?
Yes, sir.
It is quite different if you will move from one part to the another part. Right?
Yes, sir.
So have you taken care of that things while doing this research?
No, sir.
Or
No, sir. It will be done into the further work, because in these research, I only just there is no system or there is no model for to recommending the particular cardiac patient nutrition based value. So I will first try to recommend them this kind of food they can be eat, or
okay.
on the basis of that they can
Okay.
have their good health, sir.
Thank you. Okay.
Okay, okay, sir.
Okay, thank you, sir,
Okay.
for the presentation. Our next presenter is Nipala Vimla, and the paper title is Early Heart Disease Prediction Using Support Vector Machine.
Yes, ma'am. I am Vimla. Our project title is Early Heart Disease Prediction Using Support Vector Machine. Content of project objective, introduction, abstract, data collection, existing system, proposed system, implementation, output, conclusion, and at last future scope and difference. Coming to object of a project is to determine if a patient should be diagnosed with heart disease or not. Next slide, introduction. Cardiovascular disease is the leading cause of death worldwide, and the ECG is a major tool in the diagnosis. Traditional ECG signals may require experienced medical experts, which is time-consuming and labor-consuming job. To overcome this, we introduced a fully automated ECG signal using Cardio Mobile. The early detection of abnormal heart disease is vital to identify heart problems and avoid sudden cardiac death. The people with similar heart conditions almost have similar ECG signals. In order to automate detection of heart disease, an adequate algorithm is required, which is SVM, and which gives the accuracy 94.04%. Coming to data collection. How to record ECG signal using Cardio Mobile. For that, we require place both your phone and cardio device on the table and keep the distance 6 meters. You may rest your forearms and hands on table in front of you and let your fingertips rest on the cardia EKG electrodes. Make sure that both you and the mobile device remain still during ECG records, which is of 30 seconds. Movements during records will cause noise in the tracing. Coming to value extraction. Here we calculate p-value QRS complex using some mathematical notations using this diagram and generate a data set. Existing system, and it classifies a new value using k nearest neighbor values, which gives the accuracy 89.94%. It calculates a new point based on the Bayes theorem. Coming to stochastic gradient descent, it predicts to find the coming to stochastic gradient descent, to find the model parameters that correspond to the best fit between predicted and output values. And coming to proposed system, which is SVM, support vector machine. It classifies a new point based on hyperplane, which gives the accuracy 94.73%. Coming to implementation, first we need to import some packages. After that, we need to import data set. Followed by we have to remove null values and then split the training values and testing values. Train the different models like SVM, KNN, stochastic gradient descent, Navi-Bayes. Among them, which gives the accuracy, SVM gives the highest accuracy, which is 94 point something. And it creates a web page, user web page. That means it predicts the sinus rhythm, which is normal or tachycardia, bradycardia. By entering these values, we can predict the sinus rhythm. These are the outputs. Suppose if you enter the p-value in between 0.04 to 0.12, now you enter 0.04, And here PR interval is 0.08, QRS complex is 0.12. If you have any issues, previous issues means you enter yes, otherwise no. Then it predicts as you have a tachycardia. Hey, sorry. This may cause inability of the heart to pump enough blood. Heart failure. Doctor consultancy is required. It earlierly detects the problem. If you have any problem, you can doctor consult is required. Otherwise, no need. If you are coming to this slide, here it shows the normal sinus. That means no heart problem. These are the outputs. Coming to conclusion, using SVM on cardiomobile device to predict the early heart disease is a significant advancement in the field of cardiovascular health. In our opinion, heart disease can be prevented and its effects can be significantly reduced if the risk of heart disease can be precisely predicted using ECG data gathered by our cardiomobile. Coming to future scope, this project predicts people with cardiovascular disease by extracting the patient medical conditions that leads to a fatal heart disease from the data set generated based on ECG records. Differences.
Yes, basically the topic, go to your topic title page.
Yes, sir.
Okay. Now tell me the title, whatever you have presented, this work is already done. Then how your work is different from the existing work?
Using cardiomobiles, it is a device. It predicts the ECG.
Yes, it predicts the
PDF
ECG,
format.
but cardio mobile images already they are used. Then how it is different from the existing work? We are having certain papers where already cardio mobile images are being used.
Yes, sir.
So then how you can justify your work? What accuracy you are getting by using cardio mobile images?
94.73.
Okay, fine. Thank you.
Okay, thank you.
Thank you.
Yeah. So we are moving our next presenter. So next presenter is Sunina Sharma, and the paper title is Federated Learning Approaches to Diverse Machine Learning Model, a Review.
Hello everyone, good afternoon. My name is Sunana and my topic is Federated Learning Approaches to Diverse Machine Learning, a Review. Now move to the next slide. This is abstract. Federated learning is a distributed machine learning technique that allows several data owners to jointly train their models without exchanging their private and personal data. It has become increasingly popular in recent years as it provides privacy preservation, scalability to large dataset, and flexibility compared to traditional centralized approaches. Despite its advantages, federated learning also faces several challenges such as communication overhead, model stillness, and non-IIT data distribution. Now move to the next slide, that is introduction. In traditional centralized approaches to ML, there is lack of scalability and security risks. Federated learning FL addresses these problems by allowing each party with its own unique dataset to keep its data secret. Each client in the federated architecture trains the model locally, and then the server uses a learning algorithm to learn the training model approach to aggregate the data in an iterative fashion. The quality of federated privacy protection is high as FL's training method may retain data locally, which is more secure than centralized model centralized machine learning approaches. Move to the next slide. Introduction continued. In this case, it acts as a bridge to transfer knowledge from one node to another for training a robust learning model. Based on the data, there are three types of settings used in federated architecture. First is horizontal FL, vertical FL, federated transfer learning. Now, talking about horizontal federated learning is applicable in these situations where differing data sets share the same feature space but differ in samples. Move to the introduction architecture. In this architecture, each client in the federated architecture trains their model locally, and the server uses a learning algorithm to learn the training model to aggregate the data. Move to the methodology. This review considers research works conducted on the federated learning. The literature on FLs is considered for this study based on the research of IEEE Explore and Springer publication databases. The literature search was conducted using the following keywords: FL, federated learning, federated database, distributed learning, knowledge transfer, global model, privacy, security, and federated learning. Figure 2 shows the year-wise distribution of the paper. In this pie chart, I used last 5 years papers. I used 2 papers from 2023 and 12 papers from 2022 and 5 papers from 2021 and 4 papers from 2022 and 3 papers from 2019. Move to the literature review. Federated literature review key findings. Federated learning has been studied extensively with the focus on federated optimization and distributed machine learning approaches. Recently, it has also been expanded to include sports activities. Several studies have proposed new approaches using federated learning, including FedGRU for traffic flow prediction, a framework for detecting cyber attacks in vehicular sensor networks. Wait. Other studies have focused on analyzing federated learning systems, categorizing them based on different criteria, implementing them using real-world data sets, exploring their life cycle from a software engineer perspective, and discussing challenges and solutions for privacy protection and FL in mobile edge networks. There is more to the next slide. The literature review continued. There is a need to optimize ML system algorithms and data processing methods, as well as communication payload types, transmission and scheduling to reduce data traffic in distributed architectures. FL has potential uses in various wireless communication applications, including resource management, mobility management, networking, and localization at different layers of wireless networks. Move to the next slide. The use of federated learning has enabled the development of cognitive automation systems and has enhanced the effectiveness of communication in various fields, including wireless networks and IoT. Researchers have proposed various federated learning-based algorithms and frameworks for different applications, such as traffic flow prediction, cyber attack detection, and security personal data in IoT. While federated learning has great potential in improving wireless networks and IoT, there are still challenges and obstacles that need to be addressed, such as reducing data transmission costs, strengthening privacy safeguards, and optimizing ML system and algorithm for distributed architectures.
Sorry for the interruption, ma'am. Hello.
Yes, ma'am.
Ma'am, you have only 2 minutes left for the presentation.
Okay, ma'am. Sure. This is the table I used. I make from the previous papers. Next, same. Challenges in federated learning, communication cost and infrastructure heterogeneity and statistical heterogeneity and privacy concern. Compared to data center-based models, privacy is typically a major concern because federated learning utilizes a method where only the model updates are shared rather than the raw data itself. Move to the conclusion. The study reviewed recent federated learning approaches, various methodology and limitations, were found. Federated learning is used in healthcare, telecommunication, commercial, and education sectors. These issues can be resolved by using federated learning in the best environment and setting moderate trade-off between resources, performance, and architecture, complexity, and privacy. Challenges in federated learning system are depicted in the paper and need to be worked on by researchers in the future. These are the references used. Thank you. Any questions, sir?
Can you precisely tell me where we can use federated and how it can be beneficial? From the literature, your work, it is literature review, right?
Yes, sir.
So,
federated learning approach is used to train a decentralized model across multiple edge devices without sharing their personal and private data, because if we used previously we used traditional centralized approaches, and in those our data is not safe, or it is leaked. So federated learning is very safe for our data. Like we use it in companies and mobile services, mobiles, and healthcare also. In healthcare we can use it. Use it to gathering data from various locations to diagnose rare disease and autonomous vehicles. We use it in info about traffic and roads, real-time decision making, or continual learning. We can use it in manufacturing, like companies.
So what about security if we are using it in case of healthcare?
Okay. ये protect करता है. This protects sensitive data in original source and better data diversity provide.
How it works? Can you tell in healthcare? Suppose I want to have an data from number of hospitals. How it will work? Can you tell?
I don't know in deeply search.
Okay,
yes,
sir.
Thank you, sir. Thank you, sir.
Okay, thank you for the presentation, Sunaina.
Thank you, ma'am. Thank you. Thank you. Okay.
We are moving to our next presenter, Nabanita Ghosh, and the paper title is Gesture Control Interactive Radio Control Car for Rehabilitation.
Kindly unmute Divya Mukherjee as well. We had an application for that written. A very good afternoon to one and all present here. Today, I myself, Nabanita Ghosh from KIT University, currently in School of Electronics, and my co-presenter Divya Mukherjee would be talking about the topic gesture controlled iterative radio controlled car for rehabilitation. Our co-authors are Prithvi Rajra, Madhupi Karmakar, Subrahma Patnaik, and Savita Nanda. Now, the overall flow of our paper is going to be, as you can see on the screen. And now, we know that children, when they sustain serious muscular or bone injuries, the treatment includes confining the bones. So that leads to prolonged immobilization of the muscles. Now, this can cause muscular weaknesses. So this is where we got our motivation to work on a system which will help mobilize their muscles by integrating exercise movements, while at the same time in the form of an engaging activity. So that is where our work comes. That is a gesture-controlled iterative car model. So the model movements are solely based on hand movements, thus making it easy for children to control that. And our prototype ensures that exercising can be made as a fun and engaging activity for children. As per our literature survey, we found out some works which have been done where implementation of gesture control car has been done, and there the gestures were mostly taken from brisk movements of the hand. From the literature survey, the novelty, what makes our work unique to the other available work is that we have not only restricted the movement to wrist movement, we have movement of the entire arm. So that is going to ensure proper utilization of the arm, and that is more beneficial for children who needs physiotherapy. So our prototype utilizes full arm movement to take the gestures from the hands and accordingly map them on the card. Now, our device prototype is also low cost as compared to the other available models in the market, and it is also child friendly. The methodology it has, the radio controlled car runs based on the Arduino Uno board, the L293 NRF module, which is placed for communication both on the car and the hand module. The hand module has an MPU6050 module, which is used for measuring the degree of arm movement, and that data is taken and communicated to the car's Arduino via the NRF module on hand. Now, based on this data received from the MPU6050, the car moves back and forth. Now, as you can see on the flowchart, that the degree of the hand movement is received by MPU6050, and then it is sent to the RC car via the NRF module. If the hand moves from 0 to 90 degree, so in that case, the car goes in the backward direction. The hand moves from 90 to 0 degree, then the movement of the car is in the forward direction. And by 0 and 90 degree, I mean the hand is 0 degree when it is parallel to the ground, and it's 90 when it is perpendicular to the ground. Now, as the data from the arm module is sent to the car's microcontroller, then the microcontroller instructs the motor driver, which drives the motors for movement in the forward or backward direction as per requirement.
So basically, this is the working model of our car. So in the first figure, we can see that the hand positions like 0 degree is parallel to the ground, and 90 degree that is perpendicular to the ground. And in this figure 2, this is the card that we developed for our testing purpose, and this is the in figure 3, we can see the model that will be put on our lower arm, through which we can get the data. Now, moving on to the result sections. So basically, this first figure 4, the region 2 is showing the initial position, that is 0 degree for back movement. Now, once we pull our arm back, the degree will change from 0 degree to 45 degree. Once 45 degrees point is reached, the trigger will be sent and the car will start moving in the backward position. And until it reaches the 90 degree, the car will be figure 5. We can see that from 45 to 90 degree, the graph is being shaded. That means the car is continuously moving. Now, for forward movement, we can see that in the region 2, the initial position is now 90 degree. So that means our arm is in upright position, and as we move the arm forward from 90 to 0 degree, the car will start moving. As from the 45 degree position, the car will start moving until it reaches 0 degree. And in region 7, we can see that again from 45 to 90 degree, the region 45 to 0 degree, the region is shaded. That means the car is continuously moving at that point of time. So that this device system can provide a scope for future research in the field of AI, and this device can also be extended to different body parts like legs and legs, etc. So the AI and ML can be implemented along with IoT, can help the doctor to keep the track of patients and provide immediate and personalized advices. This data that will be collected from the module can be used to generate a health progress report, estimated recovery time, and so on. So this design prototype will provides rehabilitation in an enjoyment way at an affordable price. So these are some of the references that we have cited for our paper and thank you.
Okay, thank you. No questions from my side.
Thank you.
Thank you.
Thank you.
Our next presenter is M. Yashasvi, and the paper title is IoT-based signal access sun tracking solar panel.
Good afternoon, sir. My name is Yashasvi, and I'm sharing IoT-based single-axis sun tracking solar panel. So the contents here are abstract, existing system, proposed system, advantages, objectives, requirements, methodology, implementation, conclusion, and future work. So this project is the implementation of solar tracking system to generate electricity from renewable energy. The battery is used to store the energy from the solar panel through the charge controller and apply it to the intended loads. The system collects free energy from the sun and stores it on the battery and then converts this energy to the respective alternating current. So the existing system solar panel doesn't know, and it is fixed at a certain angle, and it doesn't relate to the direction of the movement of the sun from east to west. It is fixed. So here we are proposing the system, instead of taking the earth as its reference, it takes the sun as a guiding source. Its active sensors constantly monitor the sunlight and rotate the panel towards the direction where the intensity of the sunlight is maximum. And also it has a display that displays humidity, temperature of the day, and the battery percentage. The advantages of this system is that trackers generate more electricity than the stationary counterparts due to increased direct exposure to solar rays. Solar trackers generate more electricity in roughly the same amount of space needed for fixed tilt systems, making them ideal for optimizing land usage. Advancement in technology and reliability in electronics and mechanics have drastically reduced long-term maintenance concerns for tracking systems. So the objectives of this system are ability to manually rotate the tracker with the usage of a controller alongside the overall ecliptic. The solar panel tracks the sun from east to west mechanically for maximum intensity of light to consume maximum solar energy through solar tracking panels and to attain the high performance and efficiency of the solar panels. So here we require, for this one system, we require Arduino Uno, and also it is known as microcontroller, and a voltage regulator, 2 LDR sensors, solar plate, and a gear motor, and a motor driver for the motor, a 9-volt battery to store the energy received, and the loads we need, whether it has stored the energy or not. So the software requirements are Microsoft Access Database, embedded software for microcontroller. Moving on to the methodology, it is a single axis solar system uses a tilted PV panel mount and one electric motor to move the panel on an approximate trajectory related to the sun's position. The rotation axis is horizontal. Here, block diagram shows us how the system is connected. So the Arduino Uno is connected to the motor driver, which is connected to a motor, and Arduino Uno is also connected to the LDRs to sense the light intensity, and it is also connected to the load to control the voltage. And the load is connected to charge controller, and the charge controller is connected to the solar panel and battery. So moving on to the implementation, there are 2 light sensing modules placed on the board. Both the sensors send digital information about the presence and absence of light intensity to the microcontroller. The microcontroller decides the output signals for the motor driver. The motor in turn controls the orientation of the solar panel mounting structure. Based on the light intensity, the panel is moved towards the direction where the intensity is high with the help of the stepper motor. So the software implementation is like, we initialize the system and read the values from the LDRs, LDR1 and LDR2. If the light intensity is greater than the LDR2, it tilts towards the east. And if it is light intensity is more towards the west, the panel turns towards the west side. Here we show the system and the display it contains. The results and the discussions. We have conducted our system in two ways, on cloudy day and sunny day. We have shown the voltage comparisons on cloudy day for the both LDRs and on the sunny day also. So the panel at noon will be at the center as the light intensity from the both east and west are same. The panel in the morning faces east as it has more light intensity. And the panel faces the west in the evening as the light intensity observed more on the west. Conclusion. Here, a single axis photovoltaic tracking system was created and constructed in the present work using the Arduino platform. The sun's light strength was measured using the LDR light sensors. The stepper motor torque was sufficient to move the screen from east to west. The best option for Endeavour is stepper motors because they are quite and reasonably priced. This solar tracker is made to be reliable, cost efficient, and small enough to be used in remote areas. This works at the advancement in concept for green energy was intended to benefit the populace. So moving on to the future scope, it is a miniature system proposed. So it works out well. For larger solar panels, it must be integrated with the system to prepare results, best results, and cost analysis. It has been proven through our research and statistical analysis that solar tracking systems with single axis freedom can increase the energy output by approximately 20% and maybe more. Further mechanical enhancement can be done to the prototype to implement the dual axis tracking. So thank you.
Have you implemented this?
Yes, sir.
Okay. What was the energy difference in energy conservation?
So the solar panel, which is fixed constantly, has the normal reading, and the solar panel, which moves from east to west, has 20% compared to the fixed one.
Okay, so 20% rise in energy.
Yes, 20% rising.
Okay, fine. Is it compatible for the, what we can say, higher towers of solar?
Yeah, this is a miniature system, so we can implement using the high-end motors and all. Very high-end.
Okay, fine. Thank you.
Okay, thank you. Thank you.
Okay, thank you, Yashasvi. So our next presenter is Shanmuga Sundaram, and the paper title is Performance Analysis of SOC Estimation Approach for the Lithium-ion Batteries.
Yes, madam. Shall I proceed?
Yes, sir.
So good afternoon to all of you. Myself, Shanmuga Sundaram. The title of my paper is Performance Analysis of SOC Estimation Approaches for Lithium-ion Batteries. And so I'll be covering introduction, need for SOC estimation techniques, then followed by battery model, and proposed SOC estimation technique, then conclusion followed by references. So actually SOC, the state of charge estimation, is an important parameter in electric vehicle, and it has to be estimated accurately, and it is used to determine the amount of charge left in the battery for future use. Of course, there are a lot of methods available, and most of the existing methods are offline methods. And for SOC estimation, the battery parameters are used, and the battery parameters are subjected to change. under certain conditions, and this is going to affect the accuracy of SOC estimation. So in order to overcome this problem, this paper presents an adaptive SOC estimation approach employing real-time battery parameter identification and online updating observer to accurately determine the amount of charge left in the battery for future use. Okay, we know that due to this rising oil prices and rapid depletion of oil resources, and also due to environmental concerns, the demand for electric vehicle is increasing. So here, as I said, SOC, which is state of charge of the battery, it is an important parameter to be measured accurately, and based on that value only, it is possible to precisely determine the amount of charge left in the battery for future use. Actually, as I said earlier, for SOC estimation, the battery parameters are needed, but the battery parameters are not fixed. They are found to vary with change in temperature, charging, discharging rates, aging, and environmental conditions. So the existing methods which rely on fixed battery model parameters, so they are subject to change. So therefore, the SOC estimation is inaccurate. So we have to go for some adaptive methods which will take care of the variation in the battery parameters. So the existing approaches are Coulomb counting, electrochemical impedance spectrography, and also there are few observer-based techniques. So these techniques are offline techniques. Their results are the estimate SOC estimated value is inaccurate. So that is why we need an adaptive SOC estimation approach to accurately determine the charge left in the battery for future use. So here, this slide shows the conventional methods. The conventional methods are Coulomb counting, which is an offline method. It's easy to implement, but the limitation is it is not easy to measure the initial state of charge, and also the another limitation is accumulation of current sensor error over a period of time that will affect the accuracy of SOC estimation. Second one is open circuit voltage approach. This is it's less accurate method. The accuracy of this method can be improved by combining Coulomb counting with this approach. The third one is electrochemical impedance stratigraphy. So this also has some drawback, like it takes longer time to compute the internal impedance of the battery. And the final co-estimation approach, so that is a proposed approach, so where it is possible to accurately estimate the state of charge, and also the need for compensation arising due to uncertainty is totally eliminated. So coming to the battery model, so this is this model that is used for this work. So here this Q represents, right, Q represents the charge, the capacitor Q represents charging discharging cycles, whereas R0 represents a small resistance of the electrolyte, and the resistance is subject to change due to change in the state of charge of the battery, aging, and environmental conditions. And this parallel RC network. So this represents the relaxation effect of the battery. So this indicates the slow convergence of battery following charging discharging cycles. And the number of RC networks depends on the trade-off between the accuracy and complexity of the battery model, right? And if more number of parallel RC circuits are used, the circuit becomes more complex, right? So generally we use only one RC group to represent one relaxation effects, and this also will simplify the identification and extraction of model parameters. And here this graph shows the VOC SOC curve, and which is highly non-linear. So here this non-linear curve will affect the performance of the estimators. So estimators are used for SOC estimation. So what we are doing here is, we are going to split this into 8 segments, right? Each one is a linear segment, right? And we use curve fitting techniques to find best lines to fit the linear regions, right? So here there are 10 regions, right? We have created 10 regions. For this purpose, right, we are using this least square error technique. And these equations are state space equations of the battery model. So where here IL and VT represents the terminal voltage and current. IL stands for battery current, VT stands for terminal voltage, and SOC and VRC, they are considered as state variables. And for the battery with the normal capacity QR, so it is required to estimate these values B0, B1, R0, R, C, VRC, and SOC, right? By state estimation and parameter identification techniques. And this is the Simulink
Sorry
model.
for the interruption, sir. Hello.
Hello.
Sir, you have only 1 minute left.
Madam, yes, madam, your voice is very low, madam. So this is a model, Simulink model that is used here. So the parameters, right, are given as input, right? The parameters of the batteries such as R, R0, R, and C, that change according to the battery behavior was given as input, and this least square parameter identification is applied to estimate the parameters online. So the estimated parameters such as this SOC, VRC values of the previous step is also given as input to this observer, discrete LQ observer for state estimation, right? So here the battery model parameters are continuously updated and also they are identified. And the performance of the algorithm is measured by computation time and norms of error, and these are the equations represents norms of error, and computation time is defined as the time taken by the estimation algorithm to bring the estimated SOC within 5% of the reference value. So here these are the results, right? So here this graph shows the identification of battery parameters by the proposed approach. So here the parameters identified are R, RC, and R0. So here the blue dashed line indicates the actual parameter, and this red line shows the identified parameter. The identified parameter follows the actual parameter, right? So whenever the battery parameters are changed, so the algorithm also able to identify. But at the moment of change in the parameters, so there is slight error. And coming to the error norms, so the error norms for SOC co-estimation approach, then extended Kalman filter and sliding mode approaches are shown here. So it is found that norms of error and conversion time is better for the proposed approach. Then coming to this estimated SOC values of different algorithms. So here the first one, this dash line stands for SOC co-estimation. Then the red line for extended Kalman filter, and this dash line for reference, and this green line for slide mode, right? So here it is found that the SOC estimation values of extended Kalman filter is very closer to the proposed approach. And this for the sliding mode approach, so it fluctuates, right? So SOC fluctuates around the extended Kalman filter and produces large error. So the convergence time of the proposed approach is also found to be lesser than the existing approaches. So right, so the SOC estimation values of SOC co-estimation closely follows the SOC reference curves. So this proves that there is a need for adaptive SOC estimation algorithm, which uses online parameter identification as well as updating observer for SOC estimation. coming to the conclusion, so here we have implemented this SOC co-estimation algorithm and compared the results with the AKF, extended Kalman's filter and sliding mode algorithms. So it is found that the results are accurate, the parameters are identified, and so they follow the reference values. Even if there is a change in the parameters, battery parameters, so the SOC is found to be accurate, right? So in this approach, piecewise linear VOC SOC curve is used to identify the parameters, and also we have used updating observer for accurate SOC estimation. So results show that the identified parameters follow the change in the reference parameters and SOC is accurately estimated. Moreover, the performance of this SOC co-estimation algorithm is found to be better than the conventional algorithms. So coming to the scope for research, so here only simulation work is carried out. So the experimental work can be carried out again to validate this approach and also to analyze its performance. And these are my references. Thank you. Any queries, please?
You have considered the atmospheric condition. Which conditions you have considered?
Sir, that is mainly due to change in temperatures or battery temperatures.
Does it affect the battery, what we can say, charge and discharge values of?
Yes, sir. Charging, discharging rates also, it will affect, sir. It will affect the battery parameters, sir. Battery parameters, they are subjected to change, sir. Actually, for SOC estimation, we are using battery parameters. If we are going to use fixed parameters, then that will affect the accuracy of SOC estimation, sir. So therefore, we have, as and when the battery parameters changes, that should be also considered, sir, for SOC estimation. So that is why we go for adaptive algorithm, sir.
Okay. Okay. Thank you. Thank you.
Okay. Thank you, sir. Thank you. Thank you.
Okay, thank you, sir. The next presenter is P. Charithasri, and the paper title is a smart pantry system using IoT-based cloud.
Hello.
Yes, ma'am.
Is my screen is visible?
Yes, it is visible.
Okay, good afternoon to one and all. This is Charithasri Punna. The topic is smart pantry system using IoT-based cloud, and the outline. So the outline is abstract, objectives, methodology, advantages, requirement, implementation, and at last conclusion. So the abstract is the development of the IoT. So many things are automated. So the system aims to make the daily tasks of the human in the kitchen easier. So the system provides the IoT-based smart pantry level monitoring using the Internet of the Things. So the containers are fitted with the sensors. These are used to gather the data about the stock level of the items in the container. And the data is collected and stored in the cloud. The data is continuously updated through the cloud. And this information includes the changes in the weights in regular interval of time. This system enables a user to view the level of items in a container from any place. And also system alerts the user if the container level goes below the minimum threshold value, it sends a message to the shopkeeper or the to replace the order of a particular item. So these are the objectives. And our objectives are convenience, cost savings, improved efficiency, and increased accuracy. And we can remote monitoring. And the advantage of this project is automated inventory tracking, real-time updates, reduced food waste, and cost savings. So this is my methodology. Arduino is connected with the regulator power supply, load cell, ultrasonic sensor here, and mobile application and the ThinkSpeak cloud. So these are the requirements that are installed in the system. Hardware components are Arduino UNO load cell, regulator power supply, IR sensor, buzzer, LCD, Wi-Fi module, GSM module, and software components are Arduino IDE and ThinkSpeak Cloud. And Arduino UNO is the microcontroller board based on Atmega 328. It has a 14 digital input pins where 6 analog inputs and 16 are megahertz crystal oscillator. And this is the IR sensor. It gives the electrical signals as output when an object comes in front of it. By using output electrical signal, the Arduino can decide whether there is an obstacle or not. And this ultrasonic sensor, it is used as a primarily proximity sensors, which can be found in the automobile self-parking technology. And is the buzzer, which gives an efficient component to add sound features to the project. This is the LCD, which displays the panel designed to project on-screen information of a microcomputer onto a large screen. Wi-Fi module. It is easily and quickly for your Arduino Wi-Fi model, a client of your Wi-Fi network as a server to connect other client devices. GSM module. It is used to insert a SIM and get the signals of connecting through the Wi-Fi module. And the Arduino IO, which is an integrated development environment, it is used to edit the code and write the code, and where the console and toolbar with the buttons for common functions and series of menus. It connects to the Arduino and genuine hardware to upload programs and communicate with them. ThinkSpeak Cloud, it is a platform for user to gather the real-time data, for instance, climate information, location data, and other device data. And in different channels, ThinkSpeak Cloud, you can summarize the information and visualize data online in charts and analyze usual information. So this is the implementation. So firstly, we define our requirements and choose the hardware and software components which we are required and develop the software. And after that, we install the hardware and connect this hardware to the cloud. And we test the system and deploy the code into the system. And we finally update then maintain the system. And this is the data which has been stored in the cloud, and it is represented in the graphical representation. And the final our conclusion is a model which helps to keep track of agriculture fertilizer storage. Sensors can be sense the weight, level, and the object of storage containers, and they calculate the quantities of available components. The smart storage model structures one weight sensor, one level sensor, and one object sensor that can measure a different state items and report it figure back to the database. In order to make a everyday monitoring, they would have a network of weight sensors on the floor, and it will give the feedback to all feedback info into the software that will distinguish what weight sensors are carry which product's weight. Finally, we can easily find out the components which is lesser, and we can obtain it from the market, and recipes on accessible items also shown to the users. Thank you. Any queries?
No, thank you.
Yeah, thank you.
Okay, thank you for presentation. And the next presenter is Pooja A. Shelar, and the paper title is a study of architecture design for underwater wireless sensor network in the view of underwater applications. Yes, ma'am. I'm sharing my screen. Yes. Yeah, ma'am. Is it visible? Yes, ma'am. It is visible. Yeah. So good afternoon, everyone. My title of the paper was Study of Architectural Design for Underwater Wireless Sensor Network in View of Underwater Application. So the agenda for today's presentation is introduction. What is underwater wireless sensor network? Literature survey based on it. Parametric evaluation of the literature survey. Research gap which were found out. The proposed methodology and references. So what is basically is underwater wireless sensor network is nothing but collection of sensors below the water, which are connected wirelessly through the medium of acoustic waves. They work together where the data which is sensed below the water is being traveled and passed to the offshore stations above the water.
That is the only difference. TWSN, that is terrestrial wireless sensor network, if we see, it's sensor network built on the land, whereas UWSN would be the sensor network which is built below the water. So the components of acoustic UWSNs are acoustic modem, optical sensors, BOI, would be seen in the next diagram. So this is an rough diagram of what is your UWSN is. So the red color nodes are the sensors, which can be acoustic sensors, optical sensors, because sound wave can travel at a good distance in water. So mostly acoustic sensors are commonly being used. The black color, which looks like a submarine, is like a an autonomous underwater vehicle. The yellow color one is an ROV. There is a surface BOI at the top of the water surface. A ship, which is also used for transferring data from the BOI to the surface onshore stations. UWSN consists of mainly 3 communication mediums, which are acoustic, optical, and low frequency radio waves, among which acoustic communication medium is commonly used because the traveling capacity of sound wave is 100 kilometers below the water, whereas optical communications is only for 10 meters to 300 meters, which is very less enough. Whereas the low frequency radio waves travel at a distance of only 20 meters. Acoustic waves have a lower bandwidth. Optical communication medium gives higher bandwidth, whereas the bandwidth achieved with the radio frequency waves are in kbps. Acoustic are used in deep water. Optical waves are used in clean sea water, whereas radio frequency waves can be used in shallow waters. Each one has its own pros and cons. So it depends on the application on which we need to use the communication mediums. Energy, bandwidth, and sense data are very precious resources for underwater networks because energy is.
Pooja, you are having only 8 minutes. According to that plan, you are this presentation.
Yes, I will. Energy, bandwidth, and energy is precious resource because the battery of the sensors cannot be replaced below the water. Bandwidth also is very difficult to achieve. It's underwater environment itself is a challenging environment. So the sense data becomes a precious data which needed to be transferred to an onshore station. Security is also very important in this kind of networks because there are applications like enemy submarine detection, mine detection, seismic wave detection, oil spill leakage. This kind of all applications require a secure and faster data transmissions. So the objective of this literature survey was to mainly design an energy efficient, secure, and underwater application friendly architecture for underwater wireless sensor networks. So architectures are being divided into 2D, 3D, and 4D architectures. So the literature survey is trees of wheel architecture. There are various architectures being divided for underwater wireless sensor networks, like trees of wheel, tic-tac-toe, multipath virtual sync, where multiple paths are considered for transferring data. There is a swarm architecture. Aquanet is their architecture, which is used as a framework for developing various underwater applications. This is an inter and intra-cluster communication underwater wireless sensor network architecture. Again, a cluster-based architecture. Then more 90% or 99% of the architecture papers which we have gone through are almost based on the acoustic communication links. So if we compare all the architecture papers, so if we see that energy consumption is more or less in each of the paper, no algorithm or no research is based on energy efficient development of an architecture. Security is lessly considered in any of the architecture, whereas there are application specific architectures developed. Clustering used in many of the architecture designing. Some architectures are based on 3D, 2D. So if we do for parametric evaluation of the architecture, most of the architectures are based on acoustic waves only. Most of the architectures are also prone to various kinds of attacks like jamming, spoofing, Sybil, wormhole, flooding attacks. So if we find the gap analysis that the protocols are developed only on acoustic communication, so we can switch to optical communication as well, because even though if optical communications are used for lesser distances, that is 10 meters to 300 kilometers, but they provide highest bandwidth. So it can be used in a yes, ma'am. So it can be used in a combination way. Another gap was found that most of the communications overhead, there is energy consumption is least considered. So energy aware protocols were required. And security is also not considered. The key distribution mechanism can be implemented into the architectures. So the proposed architecture strategy consists of, if we divide architectures of UWSN into channel, mobility, and spatial coverage. So the channel, there are 3 channels which can be used for UWSN architecture, which is acoustic, radio, and optical, out of which we have thought of using acoustic and optical as a communication medium, which would be a hybrid mode. Mobility would be a stationary nodes. Spatial coverage would be 2D. The reason of using acoustic and optical in combination would be because positive, negative points of one are complementary in the other part. Like if we see acoustic sensors have negative points such as minimum bandwidth, connectivity loss, long propagation delays, limited energy. But the positive point of acoustic sensor was that it travels a long distance, and the acoustic sensors are quite cheaper than the optical sensors. So coming with an idea that we can use optical sensors in a cluster format where they would be deployed at a minimum distance, and for longer distance we can use acoustic sensors. So in cluster formation using optical sensors, and for relaying the data we could use acoustic sensors. So this is the proposed architecture, sir. So this architecture, we assume that it would have faster data communication, it would reduce the number of delays, and it will also provide security, because if we use optical sensors into the clusters, we can go for quantum mechanics or quantum cryptography for optical communication channels. By using the help of QKD's quantum key distribution. So the quantum key distribution security algorithms would be implemented for the clustering of optical sensors, whereas a polynomial-based polynomial-based algorithm NTRU, that is nth degree truncated ring algorithm, would be used for securing the acoustic channel communication link, which is from orange color sensor to the blue color sensor. So this way, the proposed architecture finds every link is secured with a highly secured algorithm, as well as the architecture is good enough to provide data transmission with the fastest speed and achieving energy consumption and minimum delays. So these are the advantages of the proposed architecture, that each underwater transmission link will be highly secured. Cluster-based structured data aggregation technique provides accurate data to offshore stations. The cluster-based architecture advantages only that we can provide accurate data to the offshore station. It can be used in short-term and critical applications, whereas security of data is prime concern. Due to use of acoustic and optical sensor in combination, the architecture can provide fastest data transmission with reduced end-to-end delays, and the architecture is also scalable. So this is the model number for real-time implementation. So just on research based that what we can use. It's not being still implemented. It's still research part. So it's firstly planned to have an NS3 simulation on it and then go for a real-time implication of it. So this is the overall idea, like architectural approach will provide an energy aware, secured underwater wireless sensor network. To conclude on that, every aspect it's like every aspect within underwater network is being studied. Rather, it would be a routing protocol, MAC protocol, security. But security aspect was least concerned, least focused. Rapid development in UWS and applications like from all over the world also suggests that the security in underwater sensor network should be given a very prime importance. The security algorithms developed are not fully protective and are also prone towards wastage of nodes energy. So energy conserving network was also an aim to have this literature review. This research work will be a small contribution to many developing and underwater technologies and applications, especially defense and monitoring applications. So none references. Hello.
No issues, Pooja. Good presentation.
Yeah, thank you, sir. Actually, I got it in hurry, like.
No issue, no issue. You should be in time. Next time while preparing the slides, you take care that whenever you are presenting it,
Yes,
you
sir.
will have only 10 to 12 minutes, which will be given.
Right,
Okay.
sir.
Yeah,
Yes,
yeah.
sir. Yeah, thank you.
Thank you.
Presenter is Muskan Gupta, and the paper title is Using Assemble of Different Classifier of Defect Prediction.
Is my screen visible now?
Yes, visible, ma'am.
Okay, I'll start my presentation. So, hello, I'm Muskan Gupta here, and my co-author is Ankit, and we are here to present our project, which is using ensemble of different classifiers for defect prediction. So, so firstly, I'll start with basic introduction, like what is software defect prediction and its importance. So, with continuous expansion of software scale and the enhancement of function, the complexity of software is continuously increasing. And with that, the possibility of software defects is also increasing, which can very likely lead to software failures. In this world of software engineering, software defect prediction has received a lot of interest. Defects can generally be classified as undesirable or unacceptable variations in software programs, documents, and data. For example, if the product manager misinterprets the client's requirements, defects may exist in the requirement analysis phase, and as a result, these defects may also persist through system design phase. Inexperienced coders can also be responsible for defects in the code. Thus, software defects have a huge impact on the software quality. Therefore, this concept of software defect prediction arises at the historic moment. Its main purpose is to predict software defects as soon as possible according to the basic characteristics of software, allocate test resources reasonably according to the prediction results, give test priorities, shorten the development cycle, and hence reduce the software cost. So for this, talking about the approach and present, machine learning has been widely used in this field of software defect prediction. From the existing research results, the defect prediction effect of single ML model is not very ideal. A single model either overfits or lacks the generalization ability. So hence to solve this problem, we have encouraged an ensemble learning model. Ensemble methods are basically machine learning techniques which combine several base models in order to produce one optimal predictive model. For this, the dataset we have used is GM1 dataset, which is collected from Kaggle. This dataset has 10,885 instances with 21 attributes, and the data is derived from source code extractors by McCabe and Halster. Here, maximum minimum standardization is consistently used in order to enhance the performance of model training. And also, as the data was highly unbalanced, so SMART technique, which is synthetic minority oversampling technique, is used to solve the class imbalance problem. So talking about the approach used, we have basically used 5 techniques and have made a comparison among these. So firstly, we have used SVM. So SVM is basically a popular ML algorithm which is used for classification tasks, which identifies the hyperplane that best separates the classes in this space. Next, we have used is naive Bayes, which is again a classification algorithm which basically utilizes the Bayes theorem, assuming that predictors are independent of each other. Next, we use logistic regression, where the probability of an event occurring is predicted using using logistic regression by fitting it into a logistic curve or a logistic function. Next ML algorithm is KNN, which is K nearest neighbor, which is again a ML technique according to which a sample is categorized based on the group of majority of its K closest samples in the feature space or the most comparable samples. Lastly, and the most importantly, the proposed stacking model, which stacking is basically a ensemble learning technique where two-layer estimators are used to create the classification or the regression models. First level comprises each of the baseline models, which are then used to predict the outcomes on the test datasets. And then the second layer is the regressor or the meta classifier, which generates new predictions by taking each of the predictions from the baseline models as the input. So here, this is the stacking model which I've used. In this, we have basically used 4 models, namely SVM, Gaussian naive Bayes decision tree, and the k nearest neighbor as the first layer classifier. And then the logistic regression model is used as meta classifier to build our stacking machine learning model. So this is the stacking. Next, we partitioned the data set into 80% for training and 20% for testing, and then all these machine learning models were trained and then evaluated on the data set. And the given table here shows the performance of different models based on the below mentioned metrics, which is accuracy, precision, recall, F1 score, and the AOC score. Yeah, so we have generated a chart for this also, and after seeing the results, we can basically see that after applying different ML models and ensemble them to achieve the ensemble learning, the maximum values were basically distributed in the stacking rows. Hence, we can conclude that for a traditional machine learning algorithm, which when combined with stacking model, all the evaluation metrics like accuracy, recall, F1 score, and AOC score can be improved to achieve better results of defect prediction. So actually the ensemble model or the stacking model outperforms single ML model because it is very less likely to overfit. It has poor generalization ability and it yields the most accurate results. Uh, Okay, so for the future scope, so the for the use of ensemble techniques for defect prediction has shown a very promising results. But again, the future scope for using an ensemble of different classifiers for defect prediction include firstly the use of deep learning techniques. So deep learning techniques like neural networks can be used to build ensemble classifiers. This can provide more accurate and reliable predictions for defect prediction. Secondly, integration with other software development practices. Ensemble techniques can be integrated with other software development practices like such as code reviews and automated testing, which can help in identifying defects early in the development process and hence improve the overall quality of software. And lastly, analysis of large scale software systems. The use of ensemble classifiers can be extended to analyze large scale software systems, which can help in identifying defects in complex software systems and thus improve the overall quality of the software. So that was it. Thank you.
Why you have chosen deep learning? Means is the data set that much available where you can go for deep learning techniques?
Yes, we can go for deep learning techniques, but here we have like our topic or our motive was to explore ensemble learning more. So that was the thing that in the
But
future.
we are having some issues like overfitting when we go for it.
That's why, yes, there would be some issues, and that's why I had put it in the future scope, like in we can try for basically stating that we can try for including deep learning techniques as well.
Okay.
Not right now.
Okay. Thank you.
Okay, thank you. So all the presentations are done. Authors, I sincerely thank all authors for excellent presentation and the contribution in this session. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this version and the previous 6 version. We will happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates within 2 working days through the mail. Further, all the paper have already forwarded to the swinger. The publication will be live within 6 months. So kindly cooperate with the team of ICTIS. I also thank our session chair, Professor Nilesh Popat Samle, and here is the token of appreciation on behalf of Global Knowledge Research Foundation and the team of ICTIS. So thank you so much for your valuable presence, sir.
Thank you, ma'am.
Yes, sir. So at the end of the session, I request you all please turn on the camera to keep snapshot of the virtual conference.
पर्दा ओढ़ाओ सर एक मिनट.
Thank you so much and the best of luck for the future work.